welcome guys. So in this video, let's just prove this Vandermonde identity. Okay, so this is the combinatoric identity, which is somewhat famous, right? So, okay, so the idea is that if you take the two non-negative integer m and n, so both are just non-negative integer, and then you take m plus, you choose r from m plus n, will equals to k from 0 to r, and m choose k, n choose r minus k. Okay, so let's maybe let's check some examples. So let's say 1 plus 1 1. So I choose m is 1, n is 1, r equals to 1. So it's basically k from 1 to r. So 1 1 1 k, 1 r minus k. Right, so this is 2, right? So this is just 1 0. This is 1. Okay, so 1 0 1 1 plus 1 1 1 0. So it's 1 plus 1 is 2. Okay, so this is the identity. Okay, so let's give the proof. Okay, so there are various proofs, right? So the easiest proof in the combinatorics usually involve some algebraic identity. Okay, so one famous result you need to remember is that 1 plus x to the power n will be n choose r x r from r to n. So you can view this is one way to define this combinatorics quantity. Okay. So if you notice, right, then another identity is that if you have the polynomial ring, sorry, not polynomial ring. Okay, you have two polynomial. Let's say one is ai xi, I from 1 to m, j from 0 to n. You just times it, then it becomes r from 0 to m plus n. Right, total will be m plus n, and the coefficient will be k from 0 to r. Let's say ak br minus k xr. Okay, so this is easy to prove. I think I don't want to prove. I don't need to prove it because it's straightforward, right? So for example, right, the first coordinate will be a0 plus b0. The second will be a0 b1, a1 b0 x, right, and the a2 b0, a1 b1, a0 b2 x squared. So if you see, it's clearly just this. Okay, and but there's a convention that ai will be 0 if I is larger than m, right? And j will be bj will be 0 if j is larger than n, right? Because that means that coefficient is not enough, right? But we can times 0, right? We can just replace it by 0. Okay, so now we have these two identity. One is the definition of the binomial coefficient. The second is that the algebraic identity. Okay, so the next is things trivial. What should we do? Right? What should we do? So I just times this. I just start from this one. Become r from 0 to m plus n. So m plus n r x r. Right, this is definition, and this is just equals to 1 plus x m 1 plus x n. Okay, so this is just mi xi, I from 0 to m, j from n, nj to xj. Right, so you can times these two, and then combine all of these become r from 0 to m plus n, right, k from 0 to r. So we take the first one but replace I with the k, right, and the j with r minus k. So r minus k, right, xr. So compared to this, we get our answer. So n plus n choose r is equal to mk n r minus k from 0 to r. Okay, so let's prove. Okay, so let's talk about the combinatoric proof. So combinatoric proof. Okay, so our idea is that you can consider, right? Usually, it's basically you can consider m plus how should I do this? Right, so that means just consider r, and then this is m plus n minus r. So there's a square, right? So the idea in the combinatorics, we know that the number of ways from here to go in here, right? So if you so the number of ways to from here go in here is just m plus n divided choose r. Right, so but we can just draw a line, right? We can just draw a line start from let's say k, and let's say this point is k, and m minus k, right? So so this point is k and minus k, right? And I can ask how many paths can start from 0 to k and minus k, right? So the number of is from k to m minus k, just m choose k, and the rest is asked about how many pathways from k and minus k to r and minus n r, right? So by definition, you can check that it's exactly n r minus k. Because the difference in the delta x is r minus k, and the delta y will be n plus r, n minus r plus k. So if you add these two, you get n, and then you choose x will be this, right? So from k to r, then it is well equals to this. Okay. So it's the same proof. Okay, so let's talk about another things. One generalization, right? It's an obvious generalization. Right, it's just this. This equals to, right? So I from 1 to p, and take m, right? And this is obviously correct. And the reason is that you just take the 1 plus x to the power n1, 1 plus x to the power n2, 1 plus x to the power np is equal to 1 plus x summation of I from 1 to p, and take the n's power. Okay, so that's the proof. So the idea is that exactly the same, right? Just generalize as the previous proof, but take the m's power. Okay, in the next video, I will talk about other. Maybe I will in my video list. I will take other combinatorics identity, and I hope you guys can subscribe to my channel. I'm Eric. I will see you guys in the next videos.